So for the purposes of this video, we'll be looking at the caries identified by the black dot and the distal portion of the fissure on the 6. So the first thing we need to do is create outline form in order for us to access caries. Now this involves removing overlying enamel, and we use a high-speed handpiece to remove enamel. A small round diamond tip burr creates the ideal size and shape of the cavity for accessing caries. So we're using a high-speed handpiece. You need to ensure you have a good fulcrum, and we're using coolant water to ensure we don't overheat the tooth. And we use light strokes with a gentle pressure in order to create the access cavity. And we're really using the burr to dictate the shape and the size of the cavity to remove overlying enamel only. So you can see that's quite a small cavity there. And from this diagram it's quite clear that we've only entered through enamel and we've now got the underlying carious dentine to access. So now we need to start the process of caries removal, and we remove caries with a slow speed handpiece and burr. These burrs are made of stainless steel, and you can see from the picture there that it has blades that, as the burr rotates slowly, cut into the softened dentine beneath. So again, you need a good fulcrum, and then we're going to use light strokes with gentle pressure to remove as much caries as possible in the access cavity we've created. Remove from the ADJ first and then the base. And then give the cavity a wash and a dry, and we can inspect for further caries, and we can do this using a sharp probe or an excavator. So we can see from this picture here we've removed as much caries as possible in this access cavity, but there is still quite a bit more to be removed. So in order to do that, we're going to need to widen our access cavity. So now we're going to move on to either a pear-shaped or a cylindrical burr. A pear-shaped burr, because it's naturally slightly wider at the tip, will create the retentive features we need for the cavity without us actively having to hold the burr at a certain angle. So we're going to go back to the high speed to remove the overlying enamel. And we know the overlying enamel is there and where it is because of the inspection that we did with our probe or excavator. So now the cavity is looking more like this. We've got a wider access cavity, so we'll be able to reach more of the caries. So for caries removal, we're going to go back to the slow speed burr and continue removing from the ADJ first and then the base. Slow speed burrs come in a variety of sizes, and the shape and size of your access cavity really dictates which one you use. So we're going to wash and dry the cavity again, and then inspect for more caries again using our probe or excavator. So there's still some overlying undermined enamel, and we can see from the picture here that not only is there that overlying enamel, but there's also some caries remaining up towards the ADJ. So we need to widen our access cavity again, so we're going to go back to our high speed with the pear-shaped or the cylindrical burr to remove the overlying enamel only. So now we're looking at a cavity that's wide enough to access all the caries, so we just need to go back and remove the last remaining caries with a slow speed burr again. And this process of removing caries until we need to open up the access further and going back between the high speed and the slow speed ensures the most minimal restoration possible. So here we have a cavity that is caries free. So the final design of the cavity is dictated by the material that you're using. Amalgam requires mechanical retentive features and the removal of unsupported enamel. So you can see this cavity is not suitable for it at the moment. So in order to get retention form, we need to have parallel or slightly divergent walls to retain the restoration within the cavity, and interproximal restorations also need features such as slots, grooves and occlusal locks. Now resistance form means that we need to have a flat base to the cavity to prevent the restoration from slipping due to repeat occlusal loading. So in order to create these features, we're going to need to remove more enamel and sound denting. So we're going to go back to our high speed for this, using the pear-shaped or the cylindrical bar. So here we have the final design of the cavity ready for amalgam placement. And you can see it's quite considerably larger than the initial enamel lesion might have suggested it needed to be. So before we place any restoration, we need to line the cavity. So to do this, we use a small ball-ended applicator just to pick up a very small amount of the lining material. And we apply the lining material to the base of the cavity only. Putting the lining on the cavity walls or towards the ADJ can reduce the seal of the final restoration, which could then in turn result in some secondary caries. So this is resin modified glass ionomer that we've been using, which needs light cured, so we can cure that just now for about 20 seconds. And then we can go back and use the applicator to check that the lining's in the correct place and that it's all properly cured. So when you're ready, you can ask your nurse to mix the appropriate amount of amalgam, and she'll put that into a carrier in increments so that you can place them into the cavity. So place your first increment directly into the deepest part of the cavity, and then you need to condense the amalgam into the cavity. And you use a Black's condenser for this, and you need to apply quite firm pressure. And we condense the amalgam to make sure that the cavity is properly filled. And also, in the process of condensing, a mercury-rich layer is brought to the surface. So we repeat this process of placing increments of amalgam into the cavity and condensing them well. So depending on the size of the cavity, you're obviously going to need to use a varying amount of increments. But regardless of the size, we always overfill the cavity. And that means that we can then carve the amalgam to recreate the original tooth structure. And it also means that the mercury-rich layer on the surface can be removed and aspirated away. So we can see there the cavity is quite overfilled and is now ready for carving. So we need to be quite quick when we're carving amalgam to make sure that we can get it to the right shape before the amalgam has set. So we use a carving instrument for this. This is a Ward's carver we're using here. And we can use that to follow the contours of the remaining tooth. So you're just sliding the carver along the remaining tooth and removing the amalgam required in order to recreate the fissure pattern. So we need to recreate the occlusion of the original tooth structure so that it's comfortable for the patient to bite on. But you want to avoid recreating deep fissures, because that can actually weaken the restoration. So once you've got it to the right shape, you can then move on to a burnisher, and we use this just to smooth the margin between the tooth and the restoration to make sure we don't have any plaque stagnation areas. So this is our final restoration. You can see it follows the contours of the original tooth. The occlusion is recreated, but we don't have any deep grooves or fissures.